So here's some good examples of Lewis structures um, with making actual compounds. Okay, so you can see with sodium, and this is showing you without the brackets drawn around the cation, and that's typical actually. Let's just to be consistent. Apologies. Let me erase these brackets. So we'll just say magnesium 2 plus, and that's it. Okay. So you can see sodium has one valence electron, right? There it is, okay? And chlorine has 1, 2, 3, 4, 5, 6, 7, right? So there they are, 1, 2, 3, 4, 5, 6, 7. And now this is why sodium chloride makes such a lovely pair, okay? Because now if sodium gives one of these electrons, okay, to chlorine, right? So in other words, if they undergo this redox reaction, this reduction oxidation reaction, then sodium now has the octet rule, technically, even though we say it doesn't have, we're not drawing all those electrons around it, but we remember that sodium plus is isoelectronic with neon. And now chloride, really I should say chlorine with 8 electrons, now becomes chloride. Okay, and so here is this example I showed you with oxygen, right? Becoming 2 minus, okay? And so I left myself a whole bunch of blank space, I think maybe to do more examples, which I can't think of any off the top of my head. But hopefully this makes good sense thus far, right? That we're just really for the ionic compounds, okay? We just count up the number of valence electrons it has. And the ionic compounds' Lewis structures are very simple. Bracket around the anion. Apologies for the confusion there. And we put the charge after the bracket. And then for the cation, it's just the symbol of the cation with the charge. Okay. So lots of space on the slide for you to take those notes.